Oh, hi there. Thanks for showing up for your learning. As someone that wants to learn to solve similar triangles fluently, I salute you. So, how we use this board, there's one trick to make this board work, and once you've got that trick, then there's lots of different practice that you can get, both manipulating the triangles in your mind or doing it more on paper. So I'll be showing you how to do it on paper, and then can you do it in your mind. So, in order to get these problems to work, we've got two similar triangles here. I know these triangles are similar because they share three angles. Well, I've only noted two, but if you notice, if I know these two angles, I could certainly calculate this one. And then if I calculated it on this one here, it would be the same. So knowing two angles is as good as knowing three angles. That's a little trick. Now, I'm going to need three random numbers to get this going. I'm going to put 2 on one triangle and 1 on another, and then solve for the other number. That's the whole exercise. So let's say I've got 5, 5. So I like using numbers between 2 and 12. If you want bigger numbers for your triangles, roll more dice. If you want smaller numbers, roll smaller dice. It's up to you. So 5 and 5 gives me a 10, and then 6 plus 6 gives me a 12, and I'm going to put that between the blue and red angle over here as well. Okay, I need these to line up, be on the same page. And then the 5 and 2, that's 7. That looks like it could go down there. And now I am solving for one of these sides. Okay, and maybe I'm not sure which side I can solve for in here. And that's part of what we're learning is what am I able to solve for? So my suggestion here is copy out your triangles in the same orientation. All right, so here is my 7, 10 side, and then I have to rotate that one in my mind so that I can see that that's the 12 side. Okay, and you'll notice if I put the green angles on, this green angle rotated down there, but this one I just kind of flattened out. And I put the triangles that way on my mental whiteboard so that I can see that I can solve for this side, right? Like the red angles, they rotated over here. Okay, you all want to visualize this. And to visualize it, practice copying it down. So adding this step here, it's going to make a lot of your triangle solving a lot easier. So call the one that you don't know X, if you like, or call it A if you happen to be Adam or Anisha, or call it Q if you happen to be Quentin. Anyway, call it what you want. Now we know this. X on 12 is equal to 7 on 10. To solve this equation, multiply both sides by 12, and you will solve for x. This is how I would do it. And then so you get that that's 42 on 5. Wait, how did you know that was 42 on 5? 7 times 12 is 84, and 10 is 10, but these numbers can be reduced. They both share a factor 2, so they reduce to that. And that's all there is to that. Okay, that's all you need to do, right? Let's look at this one. Okay, we're going to need, again, a few numbers. So I'm going to pick a small number there. Oh, I got two. I guess I could do 5 there like this. And that would be 4 plus 1. And then 5 plus 6. I'm going to call this one 11. And then I'm going to say that this over here is 2 plus 2 is 4. And now I'm looking for this number. Okay, so again, I'm going to make sure I'm looking for that number, clearly. So here's some things that I know. I'm going to copy out my triangles. Here's the small one, and that's 5, and that's 4. And here's the big one. When I copy it out, I see that this is 10, and that this is, if this is x, and I believe that x is measuring this distance, then this is 4 plus x. This one's actually pretty easy to solve. You can see that x is also 4, but let's see how we do that. Okay, so I know that 4 plus x on 10 is equal to 4 on 5, right? 4 plus x on 10 is equal to 4 plus 5. These ratios are the same, 4 on 5. Now we multiply both sides by 10, so we get 4 plus x is equal to 40 on 5, which is a fancy way of saying 8. And then we subtract 4 from both sides. X is 4. right? Or I can notice that this triangle is half the size of that triangle. So this length here must be double this length, meaning x is exactly 4, because 4 plus 4 is double 4. There are easy ways and there are more challenging ways. Okay, these types of configurations are more tricky, and definitely be copying out your triangles so that you can find them. This one has also been set up where that one refers to the whole length, but this refers to just this length here. Likewise with that one. So pick your poison, right? Put your unknowns where you want to practice. Okay, so let's go. We're going to need some numbers, and again, we're going to want numbers in corresponding spots. So I'm going to take a smallish number here. 2 plus 3 is 5. So I'm going to have a 5 there. And that's nice because it's the side of two triangles. Okay, so then I've got a slightly larger number here, 6. And then I'm going to actually, that's very interesting because it'll allow me to calculate that one. So this triangle, maybe make yourself some challenges and see what other numbers you can figure out. Because it's a right angle, we could actually figure out all the different things now. So with just those two numbers, let's go. Okay, what the heck is he talking about? We need 2? Okay, well, let's label our triangle. A, B, C, D, okay? And we can now copy out 3 different triangles here. Here's ABC. I'm going to write ABC this way. I'm going to put the right angle in the same spot in every case. So here's A, B, C. And I know that this is here 6. Okay, and then how about ABD? Well, I clearly have a lot of information about ABD, so I put the small triangle down there. This is my triangle ADB, and I know that this is 6, and this between D and A. ABD. I kind of don't like the way I drew that. My goodness, I flipped it, and it's ugly. So make sure you get it labeled in a way that's pleasing to you. That's the B, and that's the A. Okay, so the 6 still goes there, but now the 5 is down here. So now we can actually calculate this one here, call it x, all right? 5 squared plus x squared equals 6 squared. X equals the square root of 36 minus 25, which is the square root of 11. So that's the exact value of x. X is roughly equal to 3.4? 3.3 something? Anyway, something like that. Okay, we're not looking for that. We're looking for this down here. So we've got another triangle where that's CB. This one here, right? Well, to get that, we're going to want to work with, oh, can I? No, I can't. But I can I can still work with ACD like this. ADC. So here's my D, and then the yeah, this is my C over here, and this is A up here. So this one has a height of 5, and we can find all these other bits too as well. But it would again be from the Pythagorean theorem. So in any case, I thought we were very fancy with just the 2 numbers. We definitely need Pythagorean theorem to break into any of the other triangles in this case, but there would be other ways to label the triangle where we wouldn't. So if we know that this one is the square root of 11, how would we calculate D? Let's go ahead and do that. So we're looking for this here. We know that the ratio of this to this, and x we can calculate as the square root of 11, must be the same as this to this. So we don't know what that is, so call it y. I'm going to y over 6 is equal to 6 over the square root of 11. So that makes y equal to 36 on the square root of 11. That's what it is. So that's how you can work with that triangle. So you can see you can have Pythagorean theorem fun as well as similar triangles fun. Okay, down here, this one. With this one, you'll want to be able to recognize your corresponding angles. So if I label some angles here, if I know that this one is the same as that one, why? Because Z pattern. Those are corresponding angles, sorry, alternate angles. And that also makes over here, this one is the same as that one because they're opposite angles, vertically opposite. And then finally, this one then is the same as that one, again because of Z pattern, because they're corresponding alternate angles. I always get the names mixed up. Anyhow, so we know that. So actually, let's leave that on. Get yourself some random numbers. 5 and 4 makes 9. 5 and 2 makes 7. Apparently that triangle is smaller. And 3 and 3 makes 6. So let's put it that way. And then see what we can solve for. Redraw your triangles. If you can do this in your mind, where you have this triangle redrawn, where that's 9, and the 6th side rotated over there, that's great. And then we have this angle is there, and this angle is now here, etc. Okay. Now this triangle we can just copy across, and we'll see that we will be able to solve for this variable. Because we have 7, this angle is here. I want to set up my angles corresponding one another, and this side I don't know, so call it x. So you'll have to, part of the practice is knowing what you can solve for, and the next bit of practice is solving for it. So I know 6 on 9 is the same thing as x on 7. 6 on 9 equals x on 7. Okay, so 6 on 9 is the same thing as 2/3. So this is 2 on 3 is equal to x on 7, making x equal to 14 on 3, which is the same thing as 4 and 2/3. And that shouldn't surprise us because this got a fair bit smaller. So this is going to get a fair bit smaller as well. All right, everybody. So that's how you work with that triangle. And definitely get in this habit of drawing yourself diagrams that help you organize these things so that you can do some of them in your head. This one, for example, this one and this one are similar in that we want to remember that angle C is always angle C, angle B is always angle B, and that 90-degree angles are the same. Down here, on the other hand, this angle here is always the same. So when I get myself some random numbers, so let's go. I got 3, 3, so this side is that's gonna be, let's call this 6 here, and then we're gonna say that the biggest one here, this is we call this 7. All right, cool. And then let's say that we knew this up here was, we'll call this 8. Okay, and now we'll want to know what triangle we can solve in the small one. So it helps again to label your triangles. Call this A, B, C, and then call this Q, R for fun. All right. Now angle Q, like RQA, is the same as angle ACB because we were told so on the diagram. And angle CAB is the same as angle RAQ, right? Like this angle here is the same as this angle here. I mean, it's the same. So we want to be able to rotate our triangle in our minds or on paper to line those up and figure out what we can solve for. So let's draw angle C in the corner. So that would be angle Q in the other triangle. And angle A is always in the same place. So I actually have to flip this one. So I'm going to have Q, A, R down there, right? And QA is 6. And if I put on my angles, I'll see that this and this are in the right spot. Well, right spot, right? And then I can redraw CAB. So just redraw that so you can see it very clearly. CAB, and that's with 8 and 7, and this is still up there. And angle Q is, of course, same as angle C, because it was given. All right, now I can see I can solve for this one, so call it X. It's across from the 6, it's QR, so that's X that I can solve for. Let's find out what that would be in this case. So X on 6 is the same thing as this one on that one, top, bottom. It's the same thing as that one, top, bottom. 7 on 8. Okay, so then working that out, that gives us X is equal to 21 on 4, because that's equal to 42 on 8 when I multiply top and bottom by 6. And 42 on 8 reduces to 21 on 4. So that's another way to solve these. All right, very cool. Last one, this one. And again, you're going to want to be able to manipulate that in your mind, move the triangles. In this case, the trick is these angles are vertically opposite, so they're the same, making these angles the same. When you rename and relocate your triangles, line them up in the correct way. So I'll try one in my head here. I've got call this 3, call this 4, and call this here 8. So I can see that I can solve for this one, and it's going to be 6. That one wasn't particularly hard, was it? Because I see that the ratio here is that this is 2x longer than that one. So this also has this ratio of being 3/4 as big. So this is 3/4 as big. So that's the scale factor between the two triangles. That's how you practice the skill. All right, everyone. This is going to really help with like you're thinking about scale diagrams as well as working into trigonometry and just solving similar triangle problems with ease. Also, it's that very like puzzle-like skill of like rotating a puzzle piece, like a jigsaw puzzle, rotating these things in your mind and making sure all the information lines up in the correct way so that you can solve it efficiently. For working on these skills, absolutely, I salute you. Bye for now, everyone.